Okay, hey guys, welcome. Let's take a look at the derivative of arcsine. So I guess first, the thing that's kind of important to address is what exactly is arcsine. So arcsine is simply the inverse of sine, right? So we all know sine, we all know sine from geometry, right? It's this little wave. The inverse means that you flip the x and y coordinates, so it looks kind of like that. Okay, so now that we've gotten this out of the way, just all you have to remember is that it's the inverse of sine, right? So you flip the x coordinates and you flip the y coordinates. So let's work at deriving this. So we have y equals sine inverse, right? Arcsine and sine inverse, that's the same thing. Y equals the sine inverse of x. So the first thing we're going to do, right, is because usually we would, if we want to derive, we would just derive both sides, but we don't know the derivative of this. So we have to do some rearranging. So what we can do first is we can do the operation that would be the inverse of this operation, right? So what's the inverse of sine inverse? Well, that's kind of like, it's sine, right? Double negatives. The inverse of the inverse is the normal function, right? So we're going to do the sine of both sides. Remember that sine is just an operation. It's not a number or anything. So if we were to take the sine of the sine inverse of x, it would end up just being x, right? Because if you do the inverse operation and then you do the operation of it again, it turns out in the same number, okay? So now from here, we can actually start deriving, because we all know this the derivative of sine is cosine, right? So we'll derive again. So I can just label this step derive. That looks horrific. We'll derive. So it's cosine y times, what's the derivative of y? dy dx equals, what's the derivative of x? In this case, it's 1. Okay, so now we are in a bit of a pickle, as you can see. So the reason that these are actually kind of intriguing is that they employ geometry too. So it's a little blast from the past. So the thing you have to do here is you're going to have to make one of those triangles that you used to use all the time. And remember, SOHCAHTOA. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent, right? So the thing we're going to do here is we know that the cosine of y times dy dx equals 1. So let's get this dy dx by itself. So how do we do that? We can move this guy over here by dividing. So we'll divide this cosine y on both sides. So dy dx equals 1 over cosine y. So from here, we need to use this initial condition that we had here, that sine of y equals x, right? Because we have no idea what cosine of y is, because if we were to get cosine of y by itself, we would get that cosine of y equals dx over dy, and we have no clue what that equals. But we do have an idea of what sine y equals because we're given by this initial condition that we found here. So we know that the sine of y has to equal x. And what is the sine? Sine equals opposite over hypotenuse. So x has to equal opposite over hypotenuse. So we can make this opposite x, make the hypotenuse 1, right? And this satisfies the condition that we were looking for. So now we're trying to find cosine of y. And cosine of y requires the adjacent. And unfortunately, the adjacent is something we don't know. But we can figure out using Pythagorean theorem, the Pythagorean theorem. So we know that a squared plus b squared equals c squared. And with some rearranging to figure out what this a equals, we'll figure it out that a equals the square root of, I'll make this simpler actually. A squared equals c squared minus x squared. We want to get a by itself, so we'll square root both sides. So then we get that a equals the square root, and what's 1 squared? It's just 1, so we'll just write 1. 1 minus x squared. So we know that that's what a equals. So cosine of y thus equals adjacent over hypotenuse. So our adjacent is the square root of 1 minus x squared. And our hypotenuse is 1, so it's just that. Okay, so now we're finally ready to finish up the problem. Cosine of y equals that. So now we know that dy dx ends up equaling, right, 1 over cosine of y, but we know cosine of y is this. So the derivative of sine inverse or arcsine is 1 over 1 minus x squared. And that's your answer. Hope I helped you.